Welcome to Knowledge Center. I hope you are all doing good and also feel that you have watched my previous videos wherein I have solved some important questions from the previous question papers of Kptcl exams. Now in this video I am going to take up assistant engineer for the post of electrical question paper which has been asked in the year 2017. Now let us begin with some of the important questions from this question paper. So here comes the question number 1. In case of three-phase induction motor, the rotor power output is 30 kilowatt. If the slip during operation is 4%, then total rotor copper loss will be dash. So they have given 4 options here. So very simple thing here, they have given an induction motor which is having an output power of 30 kilowatt. And they also mentioned the slip during operation, that is 4%. So we need to know, to solve this kind of problem, we need to know the relation between the output power, slip and input power. So we have a relation in this format, that is total copper loss can be given as total input into slip. Here we need to find the total copper loss. So that's why I have mentioned this formula here. And this is very most important. In general we know that the total copper loss is of I square R, but in terms of input and slip also we can get it. So here you need to find the total input, because in question they have given the total output. So again we need to find the formula. That formula is total input can be given as total output by 1 minus slip. So we know now total output is given, that is 30 kilowatt, and even slip is given in terms of percentage. So we can simplify the data and get the answer as total input as 31,250, that is 31.25 kilowatt. Now once after getting this total input, we can substitute in the above formula and get the total copper loss, that is 31,250 into 4%. Okay. So that is the answer is 1250 watt. So for this question option B will be the answer. So before solving the question we need to have the basic idea about the formulae. So that's why I have given in detail about all the formulas which are used in the question. Now let's begin with the second question. So the second question is something like this. Here the speed of DC shunt motor running on load at rated speed can be reduced by dash. Means there is a shunt motor which is running on load. Now we need to reduce the speed of that motor. So how can we do that? So you can see the shunt motor here, wherein the field winding is connected across the armature, and the options are given here. First we need to understand the relation of speed and the other parameters in the shunt motor. Basically we have the back EMF induced in the shunt motor as follows: 5Z NP by 60 into A. But here the poles, the parallel paths and number of conductors, even that 60 is constant. So we can say that the back EMF totally depends on the speed and flux. But here we are dealing with a speed, so we can relate it like this: speed N is proportional to the back EMF EB by 5. So N is inversely proportional to the flux, and that flux is developed in the field winding here. So it shows very clear picture that if you increase the flux which has been developed in the field winding, then it is inversely proportional to speed, so speed will be reduced. So here the question is to reduce the speed. So to do that we have to increase the flux. In order to increase the flux, we have to increase the current flowing through that, because that flux is proportional to the current. So if we want to increase the current flowing through the field winding, we have to reduce the current flowing through the armature, because we know that I is equal to IA plus ISH. It's parallel. So if you reduce the current here, means if you include some resistance in the armature, look in that. If I include some resistance in the armature, then the current flowing in the armature will get reduced, but the total current I will remain same. So the remaining current will be flowing through the field winding. Then field winding will get more current, so more flux will be developed in the winding. So when flux is increased, speed will be reduced. So option C, that is connecting an additional resistance in the armature circuit, will reduces the speed of the motor. So option C will be the answer for this question. So I am explaining the questions and answers in brief so that you cannot make any mistakes in future. See, getting answer will be an easy, just giving an answer is an easiest option, but explanation is very important thing. So please watch this video till the end and with some patience. Now let's move on for the next question. So the flux in core of transformer depends on dash. So we have, without looking into the option, let us go for a relation here. We have a relation that the flux is directly proportional to the voltage, that is applied voltage by frequency. So you can say that input voltage and frequency will be the option for this question. Flux in core depends on input voltage and frequency, that is option B. Now let's move on for the another question, wherein we have something like this here. What is electromagnetic radiation with maximum wavelength? So for this, let us have this picture here. So here you can see the wavelength, the maximum wavelength is of radio waves. Okay, gamma rays is of very low wavelength. Next we got X-rays, then UV, ultraviolet rays, then visible light is under 10 to the power of minus 7. That is the wavelength of the visible light which we can see. In infrared, and then comes microwaves, and finally comes the radio waves. So radio waves will have the maximum wavelength of 10 to the power of 6. Now fifth question is related to induction motor again. The slip of induction motor normally does not depends on dash. Okay, so the slip is not dependent on what parameter, that is a point here. So for that, let us have a relation of the slip. We have a formula for the slip like this. Slip can be given as ns minus nr, that is rotor speed, by ns into 100. So by this we can directly say that the slip depends on the synchronous speed and rotor speed. So here option A and option C are avoided, we can ignore them. Synchronous speed and rotor speed are dependent, means slip is dependent on those two. Now when we have left out with a shaft torque and a coreless component. So here the slip is indirectly dependent on the shaft torque, because if speed reduces, shaft torque will also get affected. So it is again dependent on slip. Now only the thing left out is coreless component. So core loss components are not going to affect this slip. So slip of induction motor does not depend on core loss component. That would be the answer for the given question. Now let us have another question here, which is related to the switchgear and protection. I have just taken some of the important questions from the beginning stage of the question paper. So in next video we will also take up few more questions from the same question paper here. So you need to be subscribed to my channel to get the notifications of next videos also. Okay, now let us come to this question. An overcurrent relay having a current setting of 125% is connected to a supply circuit through a current transformer of 600/5 ratio. The pickup value is dash. So here very simple thing here, the current setting ratio is of 125%, that is overcurrent relay. Overcurrent relay is nothing but that relay should get activated only if the rated current is of equal or more than of 125% of the rated current. So the pickup value can be given as pickup current is equal to rated secondary current, that is the secondary current of the CT, into current setting. So here secondary current is 5, 600/5, 5 is the secondary current, and the setting ratio, current setting is of 125%, that is 1.25. So 6.25 amps is the answer. It means that the relay will get activated. Okay, the relay will get senses the extra current only if the current is equal to or more than 6.25 amps. So the option C will be the answer for this. I hope you are all understanding the concepts what I am explaining here. Definitely it may be a bit lengthy, but the thing is, understand the definitions and basic informations, then you can't make any mistakes in the future exams. Now look up into the next question. So this is also a question asked in the examination paper, but non-technical. You will also have 25 marks of aptitude questions. So this is one kind of that question. So they pick the wrong term in the series. So they are given some set of numbers. You have to identify what is the number which is wrong here. So we can see this number here. We have two set of series. This is 3, 9, 27, 81, 243. You can observe that this is the thrice. 3, 9 is thrice of the previous number. 27 is thrice of the previous number. So 3 3 is a 9, 9 3 is a 27, 27 3 is a 81. That is how we got the series here. Second series is 7 4 the 28. So it is multiplication by 4. So here I have mentioned it clearly. In first case, each of the next term is thrice of the previous term, whereas in the second case, each of the next term is 4 times of the previous term. In this process, we have 3 3s are 9, 9 3s are 27, 27 3s are 81, and 81 3s are 243. So all these numbers are correct. Now look into this second series, that is 7 4 the 28, that's okay. 28 4s are, see actually we should get 112, but we have got 84 here. And next number we should check, 112, if it is 112, 112 into 4 will get 448. So yes, we have 448 here. So instead of 84, it should be 112. So this is the wrong number we have. So option C is going to be the answer for this question. I hope it's very interesting. If you feel that the video is good and you learned something, you just comment whatever you felt about this video. Comment it about the video in the comment box. Like if you understood the concept, like it and share among your friends. And finally, don't forget to subscribe to my channel to get the notifications of new videos. Thank you guys.